Come back. Problem 4. Use linear approximation to estimate this value. So you see, power 2/3 means cube root and square. So of 64.07. So let's look for a number whose cube root you can find, which is close to 64.07. 64, cube root of 64 is 4. So that's a good close enough number, 64. So keep that in mind. Your function is x to the power 2/3. Alright, so derivative is 2/3 comes down and the power reduces by 1. So 2/3 x to the power negative 1/3, which is positive 1/3 in the bottom. Now, you are taking the number a to be 64 because 64 is close enough to 64.07 and its cube root you can calculate, you see. So, use 64 as a and write linearization. So, linearization is f at 64 plus f prime at 64 x minus 64. F at 64, my function f is power 2/3. So 64 power 2/3. F prime, that's this one. 64 1/3 in the bottom. So x minus 64 is simply part of linearization. So what is the meaning of power 2/3? Take cube root and then square. Cube root of 64 is 4. Squaring it gets me 16. Here, cube root of 64 is simply 4. So that gets me, well, 2 reduces the 4. So I get eventually 1/6 here, 16 and so on. Continue to simplify. 1/6 x plus 16 minus 64. 64 over 6 rather, right? So that is your linearization. Now I can plug in 64.07, the number whose power 2/3 you want to approximate. So when you plug in that number, you get this value and this value. Simply simplify. Look, denominator 6. This minus this, 0.07 over 6 plus 16. 0.07 over 6 plus 16. And you're done. Next problem, find the differential of this. Well, y is this. dy dx is 4x cubed plus 10. So differential dy is 4x cubed plus tan dx. So dx is already written. All you need to write is, here is derivative. Next, same thing. You want dy equals something dt. That something is going to be derivative. And you try the derivative, calculate. You need to, the derivative of this, 1 over 2 square root goes below, object inside as it is, and then times derivative of the object inside. 2's cancel and this is the derivative. So dy is the derivative dt. Alright, so notice I'm not moving this dt there because this dt is part of a phrase, derivative with respect to time. Alright, so don't confuse this with this. Here it means differential, that is change in time, and this says change in y and approximate change in y, that is dy. Regardless, the function here is going to be the derivative, which is what we have written here. That completes our section 2-9 problems. Next videos will cover chapter 3. Until then, bye.